Today I'm going to discuss some problems related to the ideas that we discussed before. Okay. So let's begin with problem number 8. This is a problem uh, that is related to the idea that we discussed at the end of yesterday's lecture, right? So in this case, we have a differential equation and it's a nonlinear differential equation because y square is appearing. So we cannot use the idea of integration factor methods. Uh, Initial condition was given and we need to solve for y. Okay. So the idea is first we have to write this function as a function of y over x. So we have dy over dx that is equal to, I'm going to divide both sides, that means both numerator and denominator by x square. Okay. So what would happen to numerator if I divide both sides? If I divide numerator by x square, that would become 6 plus 3 times y square divided by x square divided by, and I would divide xy by x square. Okay, so I would get 6 plus 3 times y divided by x square divided by I would get y of x. Okay, now you can see that this is a function of y over x. Okay. So what is the suitable substitution now? Now we have dy over dx, which is equal to some function of y over x. Function of y over. What would be the suitable substitution? Going to substitute y equals ux. This is substitution that I introduced yesterday. So first thing that we have to do is we have to express dy over dx in terms of du over dx. Okay. So I'm taking the derivative of y with respect to x. So I would get dy over dx is equal to the derivative of ux. Then I would use the product rule. Okay. So product rule would say that this is equal to u times the derivative of x plus x times the derivative of u. Okay. So dy over dx is equal to u plus x times the derivative of u with respect to x. Okay. Right. Now I'm going to replace dy over dx by this function. Okay. Now I know what is dy over dx. So again, I would go back to my original equation, right? So I would replace dy over dx by u plus x times du over dx is equal to 6 plus 3 times. Now I know that y over x. I know that y over x is equal to u. Okay. So I would write u instead of y over x. U square divided by u. I started to discuss a problem related to the idea that was related to the yesterday's class. Now let's try to find what is du over dx. Okay. Now I have u on this side. I'm going to take that u onto my right hand side. Okay. What should I get? Times du over dx equal to 6 plus 3u square divided by u minus u. Okay. And you try to continue after this point. Then the idea is you have to use separable method. Okay. Try to separate u and c. Okay. If you have any questions up to this point, you can ask. Right. I would simplify this. I would get 6 plus 3u square minus u square divided by 2, which is equal to 6 plus 2u square divided by x. This is x times du over dx. Any questions so far? Okay. Now let's try to separate our variables, right? So I would take dx to my right hand side and I would take 6 plus 2u square and u into my left hand side. So then I would get u divided by 6 plus 2u square du is equal to 1 over x dx. Okay. Right. Now my variables have been separated, so I can integrate both sides. Okay. So let's try to integrate this. Integral u divided by 6 plus 2u square du is equal to integral of 1 over x dx. Okay. Right. So from in this denominator, you can see that 2 is a common term. So I'm going to take 2 out of my integral sign. So I would get 1 divided by 2, 2 divided by 3 plus u square du is equal to natural logarithm of x plus the arbitrary constant. Okay. Right. Now, how do you evaluate this integral? How do you evaluate this integral? How do you evaluate that integral? What is the technique that you can use to evaluate that integral? Yeah, you can use a substitution, right? So let's try to evaluate. Let's evaluate the integral I equals integral u divided by 3 plus u square du. Okay. If I can evaluate this integral, I am done. Okay. For that, I am going to use t equals u square substitution. Okay. Then what is dt? dt is 2u times du. So 1 over 2 dt is equal to u du. Okay. So what is my I? I is equal to integral u du is 1 over 2 dt. And my denominator is instead of u square, I can use 3 plus u square also. So okay. 3 plus t. Okay. 1 over 2 integral of 1 over 3 plus t. Okay. Right. So what is this integral? Natural logarithm of t plus 3. Okay. Now I'm going to use the back substitution, right? I use the substitution t equals u square. So next I'm going to replace t by u square. Okay. So I would get 1 over 2 natural logarithm of u square plus 3. Okay. Now I know the integral. Okay. Now I know that integral of u divided by 3 plus u square is going to be 1 over 2 natural logarithm of u square plus 3. Okay.
We can plug in that other half. So now,
This half came from here.
oh, I know that, but the one up here, when you pull this.
No, I did not substitute for that yet.
Oh, okay.
I just evaluated this integral.
Okay.
Next time I'm going to substitute that. That I would. This was my target and I found this integral, right? The value of that integral was is equal to 1/2 ln plus 3. Okay, now I'm going to plug that. So I get 1/2 times 1/2 natural logarithm of u square plus 3 is equal to natural logarithm of x plus c. Okay. Okay. So what do we get? 1/4 natural logarithm of u square plus 3 is equal to natural logarithm of x plus c. Okay. Now what is u? We know that y is equal to ux, so u is equal to y divided by x. Okay. Next, I will replace u by y divided by x. Okay, because u is a variable that we used, right? Problem is about y and x. Okay. Okay. Now let's find the value of c. Okay. For that, I would use the initial condition that was given in the problem. What was the initial condition? Y1 equals 5. Okay. Y1 is equal to 5. Let's plug 1 instead of x, then y would be 5. Okay. Let's use the initial condition. Find the value of x. Right, so I would get 1/4 natural logarithm y1 equals 5, so I would get 5 square divided by 1 square plus 3 equals ln1 plus c. Okay, I plugged x equal 1, but if x equal 1, then y equals 5. So what do we get? ln1 equals 0. I would get 1/4 ln 28 is equal to c. So c equals 1/4 natural logarithm of 28. Okay. Any questions so far? Are you following up to this point? Any questions? Okay. Now I know the constant. Now I'm going to plug my constant to the equation. So this is my equation. So now I know the value of c. So instead of c, I would plug that value. So c is 1/4 natural logarithm of 28. Okay. And I would take that red colored piece into my left hand side. Get 1/4 natural logarithm of y square divided by x square plus 3. I'm not writing the absolute value sign because I know that the thing that is appearing inside the natural logarithm is positive. Y square is positive, x square is positive, 3 is positive, everything is positive. Okay. Minus 1/4 natural logarithm of 28 is equal to natural logarithm of x. Okay. If I take 1/4 out, I have something like this. Y square divided by x square plus 3 minus natural logarithm of 28 is equal to natural logarithm of x. Okay. Now I am going to use rules of logarithms, right? By the rules of logarithms, I can write this in this form. 1/4 y square divided by x square plus 3 divided by 28 is equal to natural logarithm of x. Okay. Then I would multiply both sides by 4. Then I would get natural logarithm of y square divided by x square plus 3 divided by 28 is equal to 4 times ln x. Okay. Right. So any questions? I'm playing with algebra, right? It's all about algebra. Right. Okay. Right. So then again, I'm using the one rule of logarithm. I have 4 times natural logarithm of x. I can write that as natural logarithm of x to the power 4. Okay. Right. So I would get natural logarithm of y square divided by x square plus 3 divided by 28 is equal to natural logarithm of x to the power 4. Okay. Right. Now what can you say about those two functions? Natural logarithm is a one-to-one function. Okay. So natural logarithm is one-to-one function. So we can say that y square divided by x square plus 3 divided by 28 is equal to x to the power 4. Okay. If I multiply both sides by 28, I would get y square divided by x square plus 3 is equal to 28 times x to the power 4. This would give us y square is equal to x square times 28 x to the power 4 minus 3. Okay. Right. This is a good problem. Right. Any questions? If you have any questions, you can ask. Okay. Let's move into a different problem now. Let's consider this problem. On the differential equation given by y dash plus 2y equals 5. Y dash means the derivative of y with respect to x. Okay. Dash is equal to dy over dx. Okay. Let's try to solve this differential equation. What can you say about this differential equation? Is it a linear differential equation or nonlinear differential equation? It's a linear differential equation, so we can use integration factor method. Okay. This is the linear first order ordinary differential equation. Let's use integration factor method. So I have the differential equation dy over dx plus 2y is equal to 5, right? So what is the integration factor? In this case, what is the integration factor? It's the exponential of integral 2 dx. Means e to the 2x. Okay, this is my integration factor. Okay. So what is my next step? I have to multiply my differential equation by integration factor. Okay. Get e to the 2x dy over dx plus 2 times e to the 2x times y is equal to 5 times e to the 2x. Okay. Then recall the trick that we used. Okay, what is the summation? Can you give a try to continue this? Take few minutes and try to continue this. What would be the next step? What is the summation? Summation is the derivative of your dependent variable times integration factor equal to 5 times e to the 2. Okay. But if you evaluate the derivative of this, right, you would get this summation. So I can replace the summation by this. Okay. That is our usual trick. Okay. So then I am using the idea that derivative is the inverse operation of integral. So can say y times e to the 2x is equal to integral of phi o e to the 2x dx plus arbitrary constant. Okay.
Aren't you gonna multiply the integration factor with the 5e to the second? X? Aren't you gonna put the integrating factor, multiply it with the integral?
Phi times e to the 2x.
And then multiply it with e to the 2x?
E to the negative 2x. Because first I replace this summation by this, right? Yeah. In the second step, I multiplied my differential equation by integration factor.
Plug it already, put it in there.
Yeah, okay. So next, I would multiply both sides by e to the negative 2x because I need y. Okay. So y equals e to the negative 2x integral phi o e to the 2x dx plus c times e to the negative 2x. Okay. Now it's easy to integrate e to the 2x. Okay. So I can take 5 out, e to the negative 2x. And if you integrate e to the 2x, you would get e to the 2x divided by 2 plus c times e to the negative 2x. Okay. So what can we say about y? E to the 2x is multiplied by e to the negative 2x. So that would become 1. And what is y? Y is a function of x. By x is equal to 5 divided by 2 plus c times e to the negative 2x. Okay. Any questions so far? Okay. Now our final goal is to find the value of the constant. Okay. So for that, we have to use the initial condition. What was the initial condition given? It's given that y0 is equal to 3. Y0 is equal to 3. So if I plug 0 instead of x, our 0 is going to be equal to 3. Okay. So c is equal to 3 minus 5 divided by 2, which is equal to 1 divided by 2. Okay. Now I know the value of c, so I can write down my final answer. So what is yx is equal to 5 divided by 2 plus 1 over 2 times e to the negative 2x. Okay. Right. Any questions? Right. Don't have any questions, we can move into the next problem. Can you give a try for this problem? It's also linear first order differential equation. So you have to use integration factors.
Does y prime equal dy over dx again?
Yeah, dy over dx. Yeah. To define the integration factor, that's our first goal.
X to the fifth. X to the fifth.
Yeah, I think let's check. Is exponential of factor is equal to exponential of integral 5 over x dx, which is equal to exponential of 5 times natural logarithm of x, exponential of natural logarithm of x to the power 5, which is equal to x to the power 5. Okay. That's the integration factor. So the next step is to multiply both sides by integration factor. I would get x to the power 5 dy over dx plus x to the power 5 divided by x times y is equal to 10 times x to the power 5 x to the power 4. Okay, that's what we get. Now I'm going to replace the summation as usual by the derivative of integration factor times our dependent variable. Equal to 10 times x to the power 9. Okay. So I have to the power 5 times y is equal to integral of 10 times x to the power 9 dx plus c. Then I would multiply both sides by x to the power negative 5. Then I would get y equals x to the power negative 5 10 times integral of x to the power 9 dx plus c times x to the power minus 5. Let's evaluate the integral. That is 10 times x to the power minus 5 x to the power 10 divided by 10 plus c times x to the power negative 5. Okay. You can see that 10 would be cancelled and get y as x to the power 5 plus c times x to the power minus 5. Okay. Right. Our final goal is to find the value of this constant c. For that, we can use initial condition. Our initial condition is y1 equals 2. Okay. Y1 is equal to 2. Okay. Let's plug our initial condition. Instead of x, I would plug 1, then y would be 2. Okay. 2 is equal to 1 to the power 5 plus c times 1 to the power negative 5. I would get c as 2 minus 1, which is equal to 1. Okay. Now I know the value of this constant, so now I can write my final solution. Yx is equal to x to the power 5 plus x to the power minus 5. Okay.
Wouldn't that be 0?
Yeah.
Wouldn't that be 0?
Power 5 and x to the power minus 5.
No.
X to the power minus 5 is 1 divided by x to the power. Any questions about this one? One. Let's do some problem related to exact differential equations. Let's do this one first. Right. Check whether this is an exact equation or not. I would replace this plus sign by minus sign by plus sign, right? Now you have some equation of type mxy. It's mxy. First check whether this is an exact equation or not. What do we have to do? We have to evaluate the partial derivative of m with respect to y. So this is the notation for that, my. My means we are taking the partial derivative of m with respect to y. It's going to be equal to 3 dabba n over dabba x is equal to in x, it is also equal to 3. So this is an exact equation. Okay. So since this is an exact equation, we know that solution is going to be f of xy is equal to c. Okay. Therefore, the differential is going to be equal to 0. Okay. Hence, dabba f over dabba x dx plus dabba f over dabba y dy is equal to 0. Now you can do some comparison. Okay. Comparison between these two. Okay. Try to figure out what is dabba f over dabba x and dabba f over dabba y. Okay. Is equal to 3x 3y and dabba f over dabba y is equal to 3x plus 4y. Okay. That was kind of second step, right? After proving the exactness, this is kind of second step. Then choose one of them and integrate, right? I would choose the first one. Choose f over dabba x is equal to 3x plus 3y. Then I would integrate. Then what would I get? fxy is equal to integral of 3x plus 3y with respect to x, and I would get a function of y since I am dealing with partial derivatives. Okay. Okay. So what would you get if you integrate this function with respect to x? You would get 3x squared divided by 2 plus 3xy plus gy. Okay. Right. Now I have an expression for fxy, but still I do not know what is gy, right? So what is the technique that we can use to find gy? Now I only use the fact that da by f over da by x equals 3x plus 3y. Okay. So the next step is to use da by f over da by y, right? For that, I'm taking the partial derivative of f with respect to y. Okay. So now I know fxy. So what is da by f over da by y? That is equal to 3x plus g dash y. Okay. By using this. Okay. And an expression for fxy, I took the partial derivatives with respect to y. Okay. But on the other hand, I know that da by 4 da by y equals this quantity. Okay. So this is da by 4 da by y. Right. So the other hand, da by 4 da by y is equal to 3x plus 4y. Okay. So these two are going to be equal. Okay. So 3x plus 4y is equal to 3x plus g dash y. 3x would be cancelled. Okay. So I have g dash y is equal to 4y. Therefore, gy is equal to 4 times y square divided by 2. Right. I get another constant, but I am not going to write that because at the end I am writing the constant. Okay. Equal to 2 times y square. Okay. Right. Now I found gy, so I can write down my final solution. What is my final solution? Going to be xy is equal to 3 times x square divided by 2 plus 3xy plus 2y square is equal to constant. Okay. Any questions about this problem? Right, so we would take a 4-minute break and continue.
Wait, no, 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 no.
Let's try this problem. Okay, let's try to solve this exact. Let's try the cross multiplication. I would get 8 cosine x minus 4x cosine y minus 10y dy is equal to negative 4 times sine y plus 8y sine x dx. Okay. If I take my left hand side to, if I take my right hand side to my left hand side, we would get 4 sine y plus 8y sine of x dx plus 8 cosine x minus 4x cosine phi minus 10 phi is equal to 0. Okay. Right. Let's check the exactness. This is the function mxy, and this is the function nxy. Okay. Evaluate the partial derivative of capital M with respect to y and evaluate the partial derivative of capital N with respect to x. If you evaluate the partial derivative of M with respect to y, you get 4 times cosine y plus 8 times sine x. Okay. Daba n over daba x is going to be 8 times the partial derivative of the derivative of cosine of x. That is negative sine x. And then I have to evaluate partial derivative of negative 4x cosine y with respect to x. That is negative 4 cosine y. This is not exact, right? Okay. So I would change the signs, right? Because I would like to have an exact equation. Then we can solve that, right? So I would remove this negative sign. A negative sign, and this would become negative. And at the end, this would become negative, positive, positive. Okay. So you would get positive. Positive. Okay. Now it is an exact equation. Okay. Equal to 8 times sine of x plus 4 times cosine y. Okay. So now this is an exact equation. So solution would be something like this. Fxy equal to p. Okay. Then what is our next step? Since fxy is a constant, its differential equals 0. So we have this relation. Dabba f over dabba x times dx plus dabba f over dabba y times dy is equal to 0. And also I have this one. Okay. Then compare these two and find out what is partial derivative of f with respect to x and partial derivative of f with respect to y. I would get dabba f over dabba x is equal to 4 times sine y plus 8y sine x, and dabba f over dabba y is equal to negative 8 sine x plus 4x cosine y plus 10y. Okay. Any questions so far? Any questions? Then we have to choose one of the partial derivatives and we have to integrate, right? In this case, I would choose the second one, right? Choose this one. Okay. I know that dabba f over dabba y is negative 8 cosine x plus 4x cosine y plus 10y. So what can you say about f of xy? This is the integral of negative 8 cosine x plus 4x cosine y plus 10y dy plus, now I had the partial derivative of f with respect to y, so I would get a function of x. Okay. So what is this integral? Negative 8y cosine x plus 4x. Integral of cosine y with respect to y is negative sine y plus integral of 10y, that is 10 times y square divided by 2. Okay. This is what I have. Right. Now I have an expression for fxy, right? Now I used dabba f over dabba y to get this expression. So my next step is I'm taking partial derivative of f with respect to x. That's what I have not used, right? So next I would take the partial derivative of f with respect to x. That is negative 8y. So, and partial derivative of f cosine x is negative sin x. That's a partial derivative. Okay. And be 4 times sine y plus g dash x. Because I'm taking derivative with respect to x, so 5 times y square would act as a constant. Okay. I would get 8y times sine of x minus 4 times sine of y plus g dash y. Okay. Right. This is da by 4 da by x. But I know that da by 4 da by x is equal to this one also. Right? So I'm using that fact. Da by 4 da by x is equal to 8y sine of x minus 4 times sine of y plus g dash y. On the other hand, that is equal to this 4 times sine y plus 8y sine x. Okay. So what would happen to 8y sine x? That would be cancelled. Okay. I think I did small mistake here. Because integral of cosine y is sine y, right? Not negative sine y. Okay. Plus. Right. Did that mistake here. Integral of cosine y is sine y. Right? Okay. Now you can see that 4 sine y is also going to be cancelled. I would get g dash y is equal to 0. So gy is some constant. Okay. Right. It should be g dash x, right? Sorry. X dx is a constant function. So now I can write down my final solution. It's going to be xy equals negative 8y cosine x plus 4x sine y plus 5y square plus gx, that is equal to k, is equal to c. K is also a constant, so you can take k to your right hand side. Okay. Finally, you can write your solution in this way. Negative 8y cosine x plus 4x sine y plus 5y square is equal to some constant c naught. Okay. Any questions about this problem? Right. Okay. Oh, 6.2. Did you all finish writing? Any questions about this problem? If you have any questions, you can ask. Okay. So I would mind different problem. Let's go into this one. Solve the differential equation given by this. Again, y prime is dy over dx. I'm planning to start Laplace transform on tomorrow. Right. And for the exam, my plan is to give 4 problems related to these 3 methods and applications and 1 problem from Laplace transform. Okay. So altogether, there would be 5 problems and 1 extra credit problem. So altogether, there would be 6 problems, right? So if you answer all the problems correctly, you get 120 out of 100. Right? So you have 20 extra credits. And get familiarized with mixing problem and how to apply Kirchhoff voltage law and current law to a circuit diagram. And if you need to use any equations, I would give those equations. And those problems will not involve very difficult computations, right? So yeah, you can use. But first you have to make the coefficient of the derivative to 1. So I would divide both sides by sin x. Then I would get dy over dx plus cosine of x divided by sine of x. Y is equal to 2 divided by sine of x. Okay. Now you can see that this is a linear first order ordinary differential equation. Cosine divided by sine, that is cotangent, right? Plus cotangent of x times y is equal to 2 times 1 divided by sine is cosecant of x. Then try to find the integration factor and continue. What is the integral of cotangent? Normally I derive that. So this is how you get that. Cotangent is cosine divided by sin x, right? You use the substitution u equals sin x. Then du is equal to cosine x dx. So this is equal to integral du over u, which is natural logarithm of u ln sin x. So this is the integral of cotangent, right? So we get exponential of natural logarithm of sin x, which is equal to sin x. Okay. Right. Now we know the integration factor, so we can continue, right? Then multiply your differential equation by integration factor and continue. Then replace the summation by our usual trick. That is, the summation is the derivative of integration factor, which is equal to sine of x times dependent variable. Okay. What can you say about your right hand side? On your right hand side, you have cosecant times sine. What is that product? Cosecant is 1 over sine. So that product is cosecant times sine is 1. So you get 2 on your right hand side. So derivative of y times sine of x is equal to 2. Okay. And what can I say about y times sine x? Equal to integral of 2 dx plus the arbitrary constant. Okay. Which is equal to 2 times x plus c. It's y times sine x. Okay. I need y. So my next step is divide both sides by sine of x. Okay. So y is going to be equal to 2x plus c divided by sine of x. Okay. Let's try to find the value of c by using the initial condition that was given in the problem. Write down the initial condition. Initial condition is y pi over 2 is equal to 2 pi. Okay. Try to use this initial condition to find the constant. Okay. Y pi over 2 is equal to 2 times pi over 2 plus c divided by sine pi over 2. This is equal to 2 pi. Okay. What is the value of sine pi over 2? It's 1. Sine 90 degrees, it's 1. So you would get 2 pi is equal to 2 times pi divided by 2, which is equal to pi plus c divided by 1. So we get c is equal to pi. Okay, so now I know y, right? Yx is equal to x plus pi divided by sine of x. Okay, this is the solution. Any question? Let's move to this problem. Again, exact differential equation. Right? First check for exactness. After simplifying, we would get 3xy square plus y dx plus 3x square y plus x dy is equal to 0. Okay. And as usual, take the partial derivative of m with respect to y. Dabba m over dabba y is equal to my is equal to 3x times partial derivative of y square is 2y plus derivative of y is 1. So I would get 6 times xy plus 1. Dabba m over dabba n over dabba x. And x is equal to 3 times y, 2x plus 1, which is equal to 6xy plus 1, right? They are equal. Hence, this is an exact differential equation. Dabba m over dabba y is equal to dabba n over dabba x. So this is an exact differential equation. Right. So that means we can solve this differential equation, right? Solution would look like this. Fxy is equal to constant, right? Therefore, the differential is equal to 0. Dabba f over dabba x times dx plus dabba f over dabba y times dy is equal to 0. Okay. Do that comparison that we did in previous cases. Compare these two, then you would see partial derivative of f with respect to x is equal to 3xy square plus y, and partial derivative of f with respect to y is 3x square y plus x. Okay. Let's try to solve this. Right. Start from any of the partial derivative that you like and integrate that and okay. So I would start from the partial derivative of f with respect to x. We have da by 4 da by x is equal to 3xy square plus y. Okay. So what can you say about fxy? Is integral of 3x y square plus y dx plus the function of y. Okay. Let's integrate this function with respect to x. So I would get 3y square x square divided by 2 plus xy. Okay. This is fxy. And I used da by 4 da by x to find this. Okay. So my next step is take the partial derivative of this function with respect to y. Okay. What is da by f over da by y? That is 3x square divided by 2. Derivative of y square, that is 2y plus x plus g dash y, which is equal to 3x square y plus x plus g dash y. Okay. Right. Then compare the partial derivative of f with respect to y that I found here with the previous one. That means with this one. Okay. Because I did not use that value, da by 4 da by y. Okay. So I can compare those two and I would get 3x square y plus x is equal to 3x square y plus x plus g dash y. So everything would be cancelled and g dash y would become 0. So gy is a constant. Okay. Right. Now I know the function g, so I can write down my final solution. So if xy equal to 3 times x square y square divided by 2 plus xy plus k is equal to c. K is also a constant, so I would get 3 divided by 2 x square y square plus xy plus k plus is equal to c naught, right? Where c naught is c minus k. Okay. Right. Any questions about that one? I have few more minutes, so I would like to recall Bernoulli's trick and some Kirchhoff's voltage law, right? So Bernoulli's trick. Right. So we know how to solve first order linear differential equation, right? But Bernoulli's trick can be used if you have something like this, right? dy over dx plus px times y is equal to fx times y to the power alpha. I hope you remember. So if you did not have y to the power alpha, then this is a linear differential equation. But y to the power alpha would give some non-linearity. Right? Alpha is not equal to 1 because if alpha is equal to 1, then this is the linear differential equation. Alpha is not equal to 1 and not equal to 0. Okay. Because if alpha is 0 again, this would be a linear differential equation. Right? So I would recall the trick, right, that we discussed. So what was the substitution that we have to use? U equals y to the power 1 minus alpha substitution. Okay, this is the substitution. Actually, you do not need to remember this. If I ask you some problem related to Bernoulli's trick, I would give you this substitution, right? And also, if you have to use some difficult integral formulas, I would give them. Okay, so this is the substitution that we have to use. So then what can you say about the derivative of u with respect to x? That is the derivative with respect to x of y to the power 1 minus alpha. Okay, then I would apply the chain rule. It is d over dy y to the power 1 minus alpha times dy over dx. Okay. So this is equal to 1 minus alpha y to the power 1 minus alpha minus 1 dy over dx. So I would get du over dx is equal to 1 minus alpha y to the power 1 y to the power minus alpha dy over dx. Okay. Then I would subject dy over dx. So what is dy over dx? That is y to the power alpha divided by 1 minus alpha times du over dx. Okay. Right. Now I have a formula for dy over dx. Next, I'm going to plug this for my original equation. Right. So this is my original equation. Right. Now instead of dy over dx, I'm going to plug this one. Okay. I would get y to the power alpha divided by 1 minus alpha du over dx plus px times y is equal to fx times y to the power alpha. Okay. Right. Then I would divide both sides by y to the power alpha. So I would get 1 divided by 1 minus alpha du over dx plus px. I'm dividing y by y to the power alpha. So I would get y to the power 1 minus alpha. And on my right hand side, I would get fx because I am dividing by y to the power alpha. Okay. Then I would multiply this equation by 1 minus alpha. Okay. Then what would I get? Du over dx plus 1 minus alpha times px times y to the power 1 minus alpha is equal to 1 minus alpha times fx. Okay, but we know that y to the power 1 minus alpha, this one is u, right? So what would I get? Du over dx plus 1 minus alpha dx times u is equal to 1 minus alpha fx. Now this is a linear ODE, right? Because u is my dependent variable. I cannot see any nonlinear functions applied on u. Okay, so this is a linear ODE, so I can solve that. Okay. This is a linear ODE. So we can apply integration factor method. Okay, that is the idea. So we can solve for u, but then we know that u equals y to the power 1 minus alpha, right? We have to do the back substitution, right? That is the idea behind Bernoulli's trick. Okay, so what is the integration factor in this case? The exponential of integral 1 minus alpha times px dx. Okay. Okay, I'll stop from this point and I'll recall our RC and RL circuits on tomorrow, and then I would move into Laplace transform. So that is going to be very important section, right? So it's not going to be difficult, but it's very important because up to now we solved only first order differential equations, but Laplace transform can be applied to solve higher order differential equations. Right. Okay.